Hello, everybody. After Phil's presentation, I would like to show you some of SRG's best practice. My name is Martin Acklin, and I'm broadcast architect and actually project manager for the DAB expansion at SRG. First, some information about us. SRG SSR is Switzerland's public service provider. We launched DAB in 1999 with 2 transmitters. We started with this 2 in Bern and Zurich. In 2012, we migrated from DAB to DAB+, and since 2025, DAB+ has replaced FM broadcasting. Actually, we have 4 ensembles, each with 16 to 17 radio stations. We have total of 236 DAB+ transmitters and 230 transmitter sites. The effective radiated power, ERP, ranges from 45 watt to 42,000 watt. And this enables us to reach 99.7% of Swiss population with DAB. To explain, we have 4 national languages in Switzerland, and that is the reason why we have separated ensembles in each language region. Here you can see the distribution. We have in the north the German-speaking Switzerland with the D01. We have on the left side the French-speaking Switzerland with F01. In the south, the Italian-speaking Switzerland with E01, and in the right side, the Red Romanish-speaking Switzerland with R01. There are other DAB layers in Switzerland, but these are operated by private companies, not by us. Before I get into our best practice, here is an overview of our topography in Switzerland. This is a significant impact on the successful construction of a DAB+ network. In the south and east, we have the Alps. They are located and with high mountains and valleys. In the north, there is the Jura. It's located in the northwest, and also mountain range that forms special separation. A mostly flat plain stretch from west to northeast, which place greater demands on the SFN design. Now let's move on to the SRG's best practice for designing DAB+ networks. The backbone is formed by the exposed high-altitude locations that the red, and their task is to cover a large area with high power. There are also exposed locations in mountains areas, but the range is limited by the topography. In mountains areas, the aim is to provide completely coverage of the valleys, the blue transmitters they are. In a final step, additional locations are needed to fill in the gaps. Something more about our network. The heart of our DAB systems is the playout, and of case of redundancy, we have 2 of them. For the deliver the ETI signals to the transmitters, we have a meshed network. The mesh network ensures that the signal connection interruption does not result in a loss of coverage. Smaller DAB+ transmitters are only connected once. The network connections are based on radio links and fiber optics. As Phil has already explained, the playout must be synchronized. Like many others, we currently do this using GPS. However, this makes it dependent on external service providers. After setting up our DAB networks, I'm focusing on timing design. In German-speaking Switzerland, we have a wide flat area stretching from west to east. It's up to 220 kilometers wide. With our high tower, high power approach, we were able to avoid self-interference. I will be happy to explain the principle to you. In the D01 network, we use 8 high power sites with more than 30,000 watts ERP. These are located a maximum of 84 kilometers apart and have time reference of 0. Additional transmitters in the network prevent self-interference. The time delay of the other transmitters depends on the distance to the nearest of the 8 high-power transmitters. For calculating purposes, the distance can be converted directly into the time delay as a guideline value. For example, a distance of 30 kilometers corresponds to a time offset of around 100 microseconds. In any case, this guideline value must be adjusted to the real condition. In the French-speaking part of Switzerland, we also have a wide flat area stretching from west to east. This area is up to 180 kilometers wide. We also used our high tower, high power design here, but we were unable to avoid all self-interference and had to take further measures. We have a high power site with 38,000 watts ERP. The other side only has 12,000 watts ERP because of interference to France. These sites have a distance of 105 kilometers between them. There is self-interference between these sites. Adjusting the time delay does not improve the situation. Another high-power transmitter is not possible because there are no suitable sites available. The only option left is to adjust the antenna pattern. The horizontal pattern can be adjusted. No emissions in the direction of the other side to the north. The vertical pattern can also be adjusted. The horizon is clear. Now I would like to share some real events from our DAB operations. All of them have something to do with timing and synchronization. It was 2019, shortly before Christmas, we received a report from our audience about sporadic audio dropouts. As you know, sporadic errors are very difficult to find. An intensive search was launched from the playout to the transmitter. It needed our broadcast experts. Our network experts had also to get involved. In the end, a network switch model was identified as the culprit in the playout. The switch was unable to forward the PDP signals correctly and had to be replaced with another model that fully supported PDP. During a network upgrade, it was only IT involved. A switch model was selected that did not meet all the necessary PDP requirements. Our learning, broadcast needs IT, but IT must be able to handle broadcast. The next issue related to the DAB coverage. We also received a report from our audience about poor DAB reception. Over time, the fault was narrowed down to a specific area. With this information, we contacted our DAB network operator. They checked all relevant DAB transmitters. They found a DAB transmitter that was not running synchronously. The DAB transmitter was immediately stopped manually. Investigations show that the modulator has synchronization problems and it's running away. The monitoring system at the DAB transmitter should have detected this, but it did not. The monitoring system was configured incorrectly. As a result, the monitoring system of all DAB transmitters were checked to ensure that they were configured correctly, and during the next maintenance cycle, all modulator units of the same design were replaced. At the DAB transmitter that is not synchronous has a poor impact on the DAB network. It can cause enormous damage. It would like to show you this. On the left-hand side, you can see the best server map. It shows which DAB transmitter provides the best coverage. The yellow circle indicates the coverage area of the DAB Plus transmitter under normal conditions. As you can see, it is small. This DAB transmitter provides coverage for 60,000 people. 16,000 people. On the right-hand side, you can see the interference zone created by incorrect timing. The interference affects 200,000 people. But also there was some GPS problems. I have collected 3 of them. At the Rigi location, the DAB transmitter had a failure of approximately 4 seconds every 15 to 20 minutes. The reason for this was a malfunction of the GPS module. At the Gebiet that's in the south of Switzerland, the DAB transmitter switched off automatically. This was because the monitoring system detected the DAB transmitter was no longer running synchronously. The reason for this was a lightning strike on the GPS antenna. It was no longer possible to synchronize the DAB transmitter. Another effect was this year. At the Zürichberg site, there was problems with synchronization. The DAB transmitter was no longer running synchronously. GPS reception was disrupted for 3 hours. The exact cause of this GPS reference malfunctions could not be determined. Finally, my conclusions. For DAB network planning, the combination of field strength, signal-to-noise ratio, and timing are the key factors for the interference-free reception. At the DAB Plus transmitter that is no longer synchronized can destroy a large area of coverage. The use of GNSS, examples GPS, makes you depend on the operator of the GNSS signal. This can be an operational risk. The SRG has also recognized this dependency as a risk. We are looking for solutions to maintain in-band synchronization.